So we are saying for a z-test, okay, for a z-test, n has to be greater than 30 and the standard deviation of the population, that is sigma, is known. That's when we use a z-test. And what will be that z? That z is going to be x bar minus nu, which is the mean of the population, divided by the standard deviation divided by square root of n. That's how we get the z. Then it is from that value of z, we go to the tables and read off that value. Then we go ahead and start making our comparisons. Okay? For a t-test, n is less than 30 and the standard deviation of the population is not known, and so we use the sample standard deviation. The sample standard deviation is obtained from this. So this is S. Standard deviation S is always equal to 1 out of n minus 1 into sum of x minus x bar squared. That will be your sample standard deviation. We already know this formula. So then what is the t? The t shall also be the mean, okay, sample mean minus the population mean divided by the sample standard deviation divided by the square root of n. So I can say this is sample mean nu is the population mean. You have to differentiate between sample mean and population mean. Population, I said you have a bigger population, for example, maybe 10,000 data points. But you choose to pick, for example, 500. So 500 will be the sample and 10,000 will be the population. So if you have the mean of this population, this is the nu. If we have the mean of this sample, the 500, then that will be the sample mean. The other one is S, which is the sample standard deviation. N is the sample size, and okay, let me use maybe here capital N so that you don't confuse the two. This should be a big N to represent the size of the population. So a small n is the sample size. Capital N is the size of the population. Then this sigma is the standard deviation of the population. Maybe Maybe you're saying using proportion p. This is another test statistic, maybe parameter that we can use. So the test statistic that we use, test statistic, will be z, okay, or t. Okay, z is equal to, let me see. So we can use also this kind of a parameter with a test statistic of this p minus the p, which is the probability of success, divided by square root of pq out of n, and q can be the probability of failure. Let's see how we